So last week was, well, a week ago, right? So what I did, the first question here looks like last week question, but it is not. What I did, I changed up the values just to refresh our memories before we move forward with some very, very new types of questions in vectors. So the question on the screen, draw the question, and I'm going to give you 5 minutes to work it out. Let's see how much you can remember. And of course, don't forget to send your answers on the chat. Correct? So for the first part, they ask us to find QP. That's this here. So we have to draw a line from Q to P. And of course, the direction is super important. To go from Q to P, I think we only have one choice. We have to go from Q to O and then O to P. So you have to put down once again the plan for the examiner. So you're going to go from Q to O and then O to P. Remember, in vectors, when you are going against the arrow, you have to make all the signs the opposite. Now, there are two ways to work this out, right? We could have it like this, or we could put it in what? Column form. The fancy way, minus 10 and 4. And once it's I and J, it's okay to write it in fancy form, where the top is automatically I, and well, the underneath is automatically what? J. For the red vector, you have an I value, but no J value. So it's minus 6, 0, right? I'm going to work it in fancy form, but to me, it just looks neater. When we're going from Q to O, seems to me we are going against the arrow. So we have to make the signs the opposite. So we have to make here positive 6, and well, 0 has no opposite. So you just leave it as 0. When we're going from O to P, we're going with the arrow. So I don't think we need to change anything here. Add up the two top values, 6 plus minus 10. Remember, a plus and a minus is a minus. So you end up with 6 minus 10, which is minus 4. 0 plus 4 is 4. And this is the answer for QP in that particular direction. So once again, don't forget your arrows. And it's good practice once you get an answer for a vector, put it into your diagram. It will help you out. How much people got that? You can have it the other way too. You can actually write it out as minus 4I plus 4J, right? It's up to you, whichever way you want to write it. All right, so people have the first answer. I'll give you a minute again for the second part, part B. All right, so let's work out the next part, MQ. Now, they said that M is the midpoint of OP. So you just have to approximate where M is. Now, last week I showed you that whenever you're trying to find the midpoint, the middle, halfway, it has to do something with dividing by 2, right? So from O to M, right, is not the entire value of the vector, right? So what's going to happen? You're going to have to divide everyone here by 2, but we're keeping the same direction. So from O to M, if we divide everyone here by 2, we're going to get minus 5 and 2, right? Great. So M to Q, right? We have to draw in what we want to find here. M to Q. There are 2 ways we can go from M to Q. M to O, and then O to Q, or M to P, and then P to Q. It really doesn't matter. Also, remember, if from here to here is minus 5 and 2, then MP, the other half, right, would also be what? Minus 5 and 2. So each half will have the same value. I'm going to go this way from M to O and O to P. So MQ, it's from M to O and then O to Q. Same rules apply. If we go against the arrow, we have to make the signs the opposite. M to O, we're going against the arrow. So this value becomes the opposite. And O to Q, well, it's with the arrow. So let's see what we get here. Out of the two top values, 5, well, a plus and a minus is a minus. So 5 minus 6 is minus 1. Minus 2 plus 0 is minus 2. How much people got this one? Minus 1, minus 2. And once again, you can write it like this. Minus 1i minus 2j. All right. Right, so the last part now. You have to find the value of PM. Well, the magnitude, sorry. PM, and when you have the two lines here, these two lines mean magnitude. Remember, when you're finding the magnitude, you have to take the I value and square it, take the J value and square it, and last, you square root the final answer. But remember, this formula only works if it's what? I and J. It doesn't work for A. It doesn't work for B. Only I and J. Right? So some people are already sending their answers, and we're trying to go to 2 decimal places. Who is right? So remember, they ask you for the length of PM. Now, from M to P is minus 5, 2. Now, if we want PM, which is the opposite way, we just have to make the signs the opposite, right? So we just change the signs of the 5 and the 2. So the top is I, the underneath is J. Let us throw it into the formula here. So it's 5 squared, that's the I value. The J value is what? Minus 2, right? Squared. And then we square root. All right? So let's work this out. 5 squared is 25. And minus 2 squared. When you square anything in the world, you will get a positive number. Even if your calculator is showing you negative 4, it's supposed to be positive 4. That's why last week I told you to make sure and put it in brackets. So 25 plus 4 is 29. When you square root 29, let's see what you get. The square root of 29, if we round it off properly, that's our calculator, give it a little bit of trouble. I'm getting 5.39. We have to round it off properly to 2 decimal places. All right. So check it back, right? I suspect some people have minus 4 here by mistake, right? I think that's the most popular mistake so far. When you square anything in the world, remember it's a positive value you're supposed to get. Well, for CXC purposes anyway, right? All right, so while you all trying this one out, there's a minor issue. When we were doing this one here from M to Q, remember, if you go from M to O and then O to Q, we're supposed to get the same answer as from M to P and P to Q. So let's see if we get the same answer. Remember, the answer we got for that was minus 1 minus 2, right? So let's see if we will get the same answer. So if you decided to do part B, but you decided to go from M to P and then P to Q, M to P and then P to Q. M to P is with the arrow, so I keep the signs as it is, minus 5, 2, and then PQ. Do I have to change the signs? What do you all think? Do I have to change the signs if I'm going from P to Q? I think so, yeah, you guys are correct. So it becomes positive 4 minus 4. And I think we're going to get the same answer, you know. Minus 5 plus 4 is minus 1. 2 plus minus 4. So 2 minus 4 is minus 2. We got the same answer. right? So that's kind of like proof that it doesn't matter which route you take. Once you start at a point and you find your way to the destination, you will get the same answer. All right, so we have two more quick revision questions. This is just the first revision question. And you see these three questions here, the A, B, and the C are super popular in the exam, like really, really super, super popular, right? So take a 20 seconds, take down anything you need to take down, and we're moving on. Right, so last week we also did a ratios question. So I changed up the values and everything here. Look, it only looks like last week question, but it's different. So they gave you a blue vector here, OA, and they told you it's minus 12p plus 7q. And they told you that OM to MA is in a ratio 1:3. Remember last week I told you ratios is just a fancy way of writing fractions. Fractions have a numerator and a denominator. To get the denominator, you add the two values in the fraction, in the ratios. 1 plus 3 is what? 4. 4 is your denominator. And the same from OM to MA is in that fraction. So OM is 1/4 of the line, and MA is just 3/4 of the line. So you just have to approximate it. Where's a quarter of the line? It's somewhere around here. Just try your best, right? So from here to here is a quarter of the entire value. From M to A, the remaining portion is 3/4 of the value. See if we can finish off part A, B, and C now, given that little jump start there. On that one. The first one is for part A, they ask us for OM. So remember, OM, well, it's in the same direction. So we just have to find a quarter of this value. If you don't like fractions, remember quarters is 0.25. And that's easy to type in on your calculator, and 3/4 is 0.75. So if the fraction is bothering you, then just change it to a decimal. Once it's an easy decimal, choose the decimal. So the entire value is minus 12p plus 7q. We have to find a quarter of this. How do you find quarter of something? You multiply it by a quarter. So we multiply everyone here by 0.25. So let's see what we get. We're going to get minus 3p, and quarter of 7 is 1.75q. How much people had that? If you had it in fraction form, is not a problem. If you have 1 3/4, even obviously if you have it as an improper fraction, it's still correct, right? So we have the value of OM. So see if you can find ME. MA is in the same direction as the blue line. So once again, you don't have to change any signs. All right. So remember, MA is 3/4 of the entire line. So we're taking the entire line, and we're going to multiply the whole thing by 0.75. 0.75 by minus 12p is minus 9p. Some people forgot how to sign. And 0.75 multiplied by 7 is 5.25q. Make sure your signs are correct as well. Wrong signs means it's wrong. And let me quickly do part C. Remember, we just found MA. Look at the answer for MA right here. From M to A is minus 9p plus 5.25q. In part C, they're asking to find AM. Isn't AM and MA opposites? Both of them it's the same vector, except they're just going opposite directions. So that means for part C, they just want you to make the signs the opposite. So minus 9p becomes positive 9p, and this guy becomes negative 5.25 Q. All right, so that's another revision question from last week. I have one more ratios question for you. I don't think we did this question last week at all, but take a 20 seconds, take down anything you need to take down as usual. Question 8. All right, so I'm going to give you all a 5 minutes with this one, right? And once again, guys, don't be too shy about sending the answers. It's the same people sending the answers over and over, about 8 people, right? So the rest of the class, try your best to get involved. Even if your answer is wrong, nothing is wrong with that once you're giving it your best shot, okay? Correct. So for this question, the ratio is 3 to 5. So from O to K, so K, and then from K to P. So K is somewhere in between here. If it's 3 to 5, we add the two values. We're going to get 8. 3 plus 5 is 8. That means the denominator is 8. So that means from O to K is about 3/8 of the line, and K to P, the remainder portion, is 5/8. So you just have to approximate it here for the example. 3/8 is over there. So OK is the entire value of the line, which is 5 minus 2. Remember, the top is I, underneath is J. And we just have to multiply everyone by 3/8. That's how you find 3/8 of something. You just multiply that by the something. Now, I know some of you are not going to like the fraction, but 3/8, as you all know, is point in decimal form, 0.375. Now, usually I go to 2 decimal places, and I'm just giving you all some advice here. Since primary school, right? Correct me if I'm wrong. Weren't you all taught how to convert the 1/8, 2/8, 3/8, 5/8, all the way down to 7/8 to decimal form? That's pretty much correct, right? In school, in primary school, did you round it off? No. You see, 3/8 is such a nice decimal. It's not like the decimal goes on forever. It's 3 decimal places. My suggestion in this case, since the 8s are so familiar, keep all 3 decimal places, please. Right? Right? So someone asks how I got the 8. 3 plus 5 is 8. That's how you get the denominator. Right? So just take my advice just one time, and of course, keep all 3 decimal places. So let's see what we get here. 0.375 multiplied by 5 is 1.875. I'm going to keep all 3 here still. And 0.375 multiplied by minus 2, I'm getting minus 0.75. The minus sign kind of hard to see there, but just darken it. How much people had that? Right? I see a lot of people did. Right? A few people got it wrong, right? Right. So we need to find KP first. All right. So for KP, it's 5/8 in the same direction of the entire vector. So we're just finding 5/8 of the vector. Once again, you all may not be too comfortable with the 5/8. So 5 divided by 8 in decimal form. So I'm erasing the 5/8 and I put in 0.625. I'm keeping all 3 decimal places. Right. 0.625 multiplied by 5 is 3.125. And 0.625 multiplied by minus 2 is minus 1.25. So we're good there, right? But we're not, are we finished with the question? What do you all think? The value from K to P is this, but we are far from finished, okay? So if, the reason, sorry, I say if, but the reason we are not finished is because it have the 2 lines here. They want us to find the magnitude of the vector. and the top is I, and the underneath is j. So to find the magnitude of the vector, we have to take this, the I value, and square it, take the j value and also square it. And what do we do last? We square root it. So work out the value there. Let's see what you get. Remember, you are going to square root last. Now, I think we went through this enough to know that we are going to square root last. So you have to work this out, add it, and whatever you get on the calculator, then we square root it. Do not press the square root sign first. So it's 3.37. Depending on how much you round off over here. But if you keep all the decimal places and you add it, and then you square root it and you round it off properly, then you're going to get 3.37, right? Roughly that. Right? If you get 3.36, don't feel too bad about it. It's just because you decided to round off on top here a little bit different. All right, so great. Let's see what's next here. Oh, you get a little cutscene. Remember this from last week? Choose a color, guys. Let's see if luck is on your side tonight. Will you get something good? Will you get something bad? And you cannot change your mind, right? If I were you, I would probably choose blue. Let's see what you guys got, if you're lucky tonight. So for those who chose red, I guess you got the worst deal out of all of them. All right, but even if you win 25 cents, that's 25 more cents than you had before. Somebody said it chose yellow. Well, for those who chose orange, congrats. All right, so let's move on. All right, so my mistake, we're still not ready to go on to factorizing vectors. This here is actually a past paper question. I just changed up the values, right? We're going to go through this question together. Take a minute, draw everything, take down the entire question, and we will start this as a team. All right, quick question. Look at this diagram. And the first piece, the first sentence, LQ. Do you all see Q on that diagram? Is Q written in for you? And the answer is no. And this is exactly how the examiner brought it up. Q is nowhere in the diagram, and you're trying to figure out where Q is. What it's saying, LQ is twice LM. So in other words, if you want to journey from L to Q, you have to move twice the distance of LM. So to go to Q, you have to go LM once and then LM again. But this is supposed to be a straight line, right? Obviously, it's a little bent here because I don't have a ruler on me. And if we do that and continue the same direction, twice the distance, we will eventually reach what? Q. Everybody with me so far? And yeah, this is given at the beginning of the question. LQ is twice LM. When you multiply something by 2, you're really doubling it or finding 2 times the amount, right? So let's put this in perspective, right? In terms of money, who has more money? If I tell you LM has $5, how much does LQ have? Well, what do you all think? If LM is $5, how much is LQ? $10, right? Because the examiner said LQ is, to find LQ, you have to take LM and multiply it by 2. There's a secret multiplier in between here. So that means LQ is 2 multiplied by 5, which is 10. So LQ is twice LM. So I hope that clears it up there for those who didn't catch it the first time, right? So another question now. We know from L to M, let me get a different color going here, right? To make it a little bit easier to understand. This is the extension here to reach Q. If from L to M is minus 4a, what's the value from M to Q, the blue portion? Provided, well, if it's a straight line, that means the black line and the blue line moving in the same direction. MQ, no, Scott, you have it slightly wrong. I asked for the distance from M to Q, the blue part only. MQ is minus 4a also. Scott, you answered right. You have it correct now, Scott. Great. Because from L all the way to Q now would be minus 8a, but the blue portion alone is minus 4a. Do you all, well, I think I answered the first part already. If they ask you for part A, they ask you how much is LQ. LQ is minus 8a, right? Going from here to here is minus 4a, and then another minus 4a. That's minus 8a. Do you all think you all can find this one for me now? QN, right? Right, I just want to erase this there. So the answer over here, right? Minus 8. Draw in what you want to find. QN. Get different color, or get green. Q, oh, that's supposed to be a straight line. Unfortunately, it doesn't look so. How can you reach from Q to M? Q to M, M to L, and L to N. Or you could just say Q to L in one shot, and then L to N. Anyone is going to give you the same answer. Right, so let's work this out. To go from Q to N, so we have to put on the plan for the examiner. To go from Q to N, we could go, well, we could break it up into 3 parts, right? We could journey from Q to M, M to L, L to N, right? Even if you go from Q to L in one shot, you're going to get the same answer. So but I'm going to break it up. Q to M. Once we reach M, we journey from M to L, and then L to N. How much is QM? QM, remember, MQ, this is the value for MQ, but now we're going against the arrow. So he becomes positive 4a. And then from M to L, we're going against the arrow again. So he is positive 4a as well. And then LN, but he is with the arrow, so we don't need to change him, right? So if you add up the 2 A's, you're going to get 8A plus 5B. But you notice my answers has an A and a B. Is it okay to say 13AB? Which is what a lot of people sent, right? Too much people send that. The answer is no. By now, guys, we should be supposed to have this cleared up. 8A cannot be squished together with 5B. A and B are 2 completely different letters. This here is your final answer. And some people did this. 8, 5. Is this one okay? We are not multiplying. This is adding, right? 8A plus 5B. Right, remember, if you write it like this in fancy form, you're assuming, you're telling the examiner the top number is I and the underneath number is J. This question has nothing to do with I and J. Remember last week, we said over and over and over, fancy form is only reserved, column form, vertical form is only reserved for I and J, right? At least try your best to do that, right? Otherwise, the examiner is going to misinterpret it. Right? Right. All right. So let's take a 20 seconds. Let's see what's next here. All right, factorizing vectors. Now, factorizing vectors is all about putting vectors in brackets. And there's a good reason that you will want to put vectors in brackets. Now, factorizing is something we did last term, right? But I know you're going to need a little refresher. So let's factorize this expression here, this vector, OA. And I also want to remind you what we mean by factorizing. It's a certain term we're going to use. In this expression, if you have to factorize it, what's the easiest thing to pull out? Which number can go into 3 and 6 at the same time? 3, right? And that comes off the top of your head, right? A lot of people are shouting out 3. So if you decide to pull out 3, which is how we say it in Trinidad, right? You pull out a number. So we pull out 3, so we put the 3 outside the brackets. But what does pull out 3 mean? Pull out 3 means we are visiting everybody involved and dividing them by whatever we are pulling out, which is 3. So we divided everyone here by 3. 3 divided by 3 is 1a. You don't have to put the 1 if you don't want to, but if you want to, feel free. 6b divided by 3 is 2b, right? I actually don't want to put a 1. It looks not mathematical enough. This is the simplest question in factorizing you can probably hope to get in a CSEC exam. Now, the yellow question is easy because we know 3 could go into 3 and 6. But look at the blue question. Is there anything obvious to pull out? What could go into 4 and 5 at the same time? And the answer is going to be what? Well, you're not really allowed to pull out 1, right? If you pull out 1, it's not going to really change much. In vectors, let's say you're forced to factorize. Like, this is not an easy question to factorize, but the examiner is insistent, hey, factorize it, and he doesn't care. Whenever you're not too sure what to pull out, here's my advice. Just look at the first number. What number we see? 4. So we say, all right, we're just going to pull that out. So if we decide to pull out 4, right, what does that mean? We're visiting everyone and dividing them by 4. 4 divided by 4 will leave you with the A. 5 divided by 4 is 1.25b. If you don't trust me, type it in on the calculator. 5 divided by 4. The truth is, right, and I'm going to show you something. In factorization, it doesn't matter what you pull out. There's no rule. Look, let's go back to the yellow question. There is no rule in maths that says that you have to look for a number that could go into the 2 numbers, There's no rule. It's just if there's a number that can go into both numbers, then that would be an easiest course of action to finish the question. For example, let's say I go to another planet and I ask them to factorize this, and the aliens look at it. An alien can say, well, I don't want to pull out 3. I want to pull out 8. 8 can't go into 3 and 6. But if he decides to pull out 8 and he divides everyone by 8 and gets 0.3758, and over here you'll get 0.75b because we divide everyone by 8. This is mathematically correct also. That is 100% correct as well, right? Everybody with me so far? When you're factorizing, it doesn't matter what you pull out once you divide everybody by that number. But if there's an easy number to pull out, by all means, choose that easy number. But if there's no easy number, my advice is just look at the first number and pull out that number. All right? How about this pink one now? Look at this pink one here. This is fractions. And believe me, you're going to bounce up a lot of fractions. So you've seen 2/3 and you've seen 4/5. And of course, you're like, oh my God, what am I going to do in the exam? Don't make it a problem. Look at the first number. It's 2/3, right? That's the first value. So that means we're just going to simply pull out what? 2/3. So we're going to visit everybody here and divide him by 2/3. Visit him and divide him by 2/3. You think you all can work out this for me? Well, 2/3 divided by 2/3 is 1. The 2/2 will cancel out, leaving you with A minus. You just have to figure out how much is 4/5 divided by 2/3. You think you all can do that for me? 4/5 divided by 2/3 and put a B after. All right, so let's see. So we're going to take 4/5, that's this, and divide it by 2/3, which is this. In primary school, the divide will change to a multiply, and thing after the multiply will invert, right? 2 into 2 is 1, 2 into 4 is 2, 2 by 3 is 6 divided by 5. So it's 6/5, and well, 6/5 is the same thing as 1.2. So you can either put 1.2b or 6/5. The working is over here on how to divide fractions. But I know most of you all will just use your calculator just to divide it, okay? And if you want to put it in improper fractions, is mixed fractions, is 1 and 1/5. Obviously, any one is correct. All right, so take a 20 seconds, and we're moving on. All right. So we're going to do something called collinear vectors. Before you take down anything on the screen there, let me explain what is collinear. Everyone knows at least what is parallel lines, okay? Like if I have the line AB and I have CD, right? These two lines are parallel. Well, what do parallel lines mean? Parallel lines are two lines that will never, ever, ever meet because they're going in the same exact direction. And by the way, parallel lines do not touch each other. You notice AB does not touch CD. So what is collinear, right? If I were to take point C and D, the line CD, and slide it upwards so that C touches B, right? So C now touching where B was, right? So let me draw that a little better. Would we get a perfect straight line? If two parallel lines were to slide and meet each other, would we get a perfect straight line? Use the imagination. I think the answer is yes, 100% yes. Because we keep in the same we keep in the same direction. We just sliding it upwards so that B and C meet. Obviously, this from A to B and C to D is definitely going in the same direction. In other words, collinear is a perfect straight line. So whenever they use the word collinear, like they ask you to prove this vector is collinear, they're really asking you to prove A, M, and K form a straight line. That's what collinear means. Oh, I have it up here. I didn't realize that. I'll write it here. Collinear means a perfect straight line. Now, how do you prove vectors are a straight line? You just can't look at it and say, hey, well, it looks straight, and tell the examiner in writing, hey, they look straight, hence they're collinear. He doesn't want that. He wants mathematical proof that the vectors are collinear. So how do you prove it? All you have to do is take the three letters involved. So what are the three letters? A, M, and K. So everyone write down the three letters, A, M, and K. If the letters were P, Q, and R, you just put P, Q, and R in the same order that they have it on the screen. A comes first, M comes second, C comes third. K comes third. When you do that, I want you to circle the first two letters and find that vector. Now, this question is easy because I gave you the vector from A to M, right? This is supposed to represent from A to M. Usually, you just have to find it. But let me pretend we found it, and A to M was 3A minus 5B. Then you circle the last two letters, the second and the third letter. You know, find it looks like a Venn diagram. You circle the first two letters and then the second two letters. And then you find that vector. Now that vector happens to be, I already found it for you, is minus 6a plus 10b. Are those two vectors the same? The obvious answer is no. One is the pink one is a different value from the black one, right? Both of them are completely different values. Now are they saying if the pink value and the black value was the same, then automatically they would be collinear. But 99% of the times in the exam, the two values would be different. So to prove they are collinear, you have to factorize the pink expression and the black expression. So let's do that now. For the first expression, I'm going to pull out what? 3. Because when you don't know what to pull out, just take the first number and just pull that out, right? We're dividing everyone here by 3 if we decide to pull out 3. 3 divided by 3 is 1, so you get A. I'm just going to put the fraction over here because 5 divided by 3 will give you what? A reoccurring decimal, 1.666666. I'm not a fan of reoccurring decimals. So I'm just going to put 1 and 2/3 B because you will get 1 and 2/3 here. And you do the same thing for the black expression. You don't know what to pull out, just pull out minus 6. Make it easy. Divide everyone here by minus 6. Minus 6 divided by 6 leaves you with A. Positive 10 divided by minus 6, if you don't trust me, try it on the calculator. You will get minus 1 and 2/3. If after factorizing it, right, you get them to look the same, I'm talking about inside the brackets. You're just looking at inside the brackets. Once you get them to look the same, you have just proven it was collinear. So after you get them to look the same after factorizing, you just write a sentence. Hence, they are collinear. Easy enough, guys? All you're doing is factorizing the two vectors to make them look the same in the brackets. That is how you prove two vectors are collinear. As simple as that, right? You can also use the same method to prove that two vectors are parallel, because parallel and collinear are closely related, right? Everybody with me so far? Let me know in the chat, right? Only one person replied. The easier way to prove two vectors are parallel, right? Remember, the first vector was AM. We have it here. All you have to do is take the second value and divide it by the first value. So you have an A value and a B value. So all you're going to do is just take the second value and divide it by the first value. Make sure and keep the signs. You're not dividing the letters, huh? It's just the value. So the second value is what? Minus 5. And the first value is 3. If we divide this, we'll get what? Minus 1 and 2/3. Do the same thing for the other vector to prove it's a straight line. Take the second value, which is 10, and divide it by the first value. I guarantee you, if you divide this, you will get the same thing, minus 1 and 2/3. Once you get the two values to be the same, that's proof that they are also what? Collinear. But you have to write down the 3 letters first, and circle the first 2, find that vector, circle the last 2 and find that vector. But remember, once again, it's already been found for you because I did it beforehand. How much of y'all agree the second method is easier? Because the second method has nothing to do with factorizing. You're just taking the second value, dividing by the first value. And if you get them to look the same, then they're collinear. My advice is stay away unless you have no choice. And there are very rare occasions where you have no choice but to use the easier method. Let me explain why. I just don't want to tell you that. I want to explain why. If you look at the harder method, right, you notice both vectors are the same after factorizing. But what number you have in front here? 3. And what number you have here? Which vector do you think is larger? Remember, the first one was AM, and the other one was what? MK. From looking at these values that are in front of you, which one is larger, AM or MK? I would think MK, right? Because this one is the same vector, but you have 3 of it. And this, forget the sign for the time being. And the second one is the same vector, but you have 6 of it. Is it fair to say that MK is twice the size of AM? Because 6 is twice the size of 3? Right. So in other words, MK is twice the size of AM, and the minus sign just means it's going in the opposite direction. That is all. But the main point is MK and AM, you can tell which one bigger and which one is smaller after you factorize it. In this easier method, can you tell which one is larger? And the answer will be no. You would have no way of knowing which one is larger. And the examiner loves to ask at the end of a collinear question, which one is the larger one? And then he'll ask you, how much times larger? So why waste your time doing the easier method? Because to figure out which one larger and how much times larger, you're going to have to use the factorization method. So just stick with the harder method unless you have no choice. And don't worry, I'll show you a question eventually where you have no choice but to use the easier method. Great. So take a 20 seconds. Once again, take down what you need to take down, right? Make a note. Let me write it here. AMK is twice the size of AM. And you know that because one is 6 and one is 3. 6 is twice the size of 3. And the minus sign, once again, just means MK is going the opposite direction. That's what a minus sign means in vectors. Goes the opposite direction. Oh, a little break after that that long explanation. Choose the color, guys. Which one you feel lucky with, blue or orange? Most people going with the blue. Only 2 people so far have said orange. Let's see if we get lucky here, guys. Oh my. For you, those of you who chose blue, you should have gone with orange. All right, let's move on. All right, the thing you all could prove that these 2 vectors are parallel, not parallel, they are collinear. I want you to use the long method. Factorize both of them. Don't get intimidated by the fractions. Most likely in the exam, you're going to get a fraction. Very rare, you just get a whole number in these collinear questions. Let me know when you're finished. Let's get started. Let's do the first one. For the first one, I want to pull out a half, right? So there's some space here. So if I decide to pull out a half, what I am doing for PQ, well, this is for the PQ part here. Remember, it's P, Q, and M. You gotta find PQ first. So I'm finding PQ here. I'm dividing everyone here by a half. Dividing him by a half, dividing him by a half. Half divided by half is 1. And 4/5 divided by a half. I just book it into the side here. 4/5 divided by a half. In primary school, the divide changes to a multiply, and you flip this. 2 on 1. 4 by 2 is 8 on 5. So you'll get 8 on 5 or 1.6. So 1.6 B. So this is for PQ. So this one has a half in front of it. The other one, you're going to have to pull out a quarter. So that would be QM. By pulling out a quarter, dividing everyone here by a quarter. Quarter divided by a quarter is 1. And for those who want the calculations, 2/5 divided by a quarter divide changes to multiply, flips. 2 by 4 is 8 on 5. Minus 1.6b, and you have a quarter here. Which one is larger, PQ or QM? Look at the values in front. This one has a half and this one has a quarter. Which one is larger? PQ or QM? You all are correct. It's PQ. How much times larger is PQ? Because a half is larger than a quarter. How much times larger is PQ? Like if they ask you that, how much times larger? Caitlin, correct. Right. Dina, correct. Take one more answer. No, Rebecca, wrong. Right. It would be twice. Isn't a half twice the size of a quarter? If you have a cake and somebody gives you half a cake and somebody gives somebody a quarter of a cake, isn't a half twice the amount of a quarter? So PQ is twice the size of PQM. All right. So take down what you need to take down, right? All right. Now, this is over here. Now, I think I explained that parallel and collinear are slightly different, right? But I have an official note here. In collinear, the two lines are actually joined together to give you a straight line. In parallel lines, the two segments, the two blue lines here are in the same direction, but they don't actually touch each other, okay? So you can think of collinear as a special case of parallel. Collinear is when two parallel lines actually come in contact with each other. So I needed to take down everything on the screen here because it's so easy to mix up collinear and parallel. And because collinear and parallel are so similar, you could use the same method to prove two vectors are collinear or parallel. Right? Right. All right. So here's an easy piece of theory, right? Everyone draw this diagram and take down the question, including the yellow note on top, right? All right. So the rule, this here is a real simple rule. If you have two vectors that are parallel, right? And they have the same length. They just can't be parallel alone. They must have these two qualities, parallel and the same length. They have the same exact value. So quickly, before we start to answer this question, this is supposed to be a parallelogram, right? Now the examiner is supposed to tell you that in the exam, right? Okay. In case you can't remember what a parallelogram is, the opposite sides of a parallelogram are parallel, hence its name, and they have the same exact length. So without any calculations, who can tell me what's the value of CB? The examiner only gave you OA and OC, but he left out CB. Right, and it's straight out of the note here. It's not even a trick question. It's minus 10B, okay? So from C to B, because it have the same length and is parallel to this vector, no calculation involved. They automatically have the same length. And of course, A, B, and O, C have the same direction, they parallel, they have the same length. So this is 2A minus B. All right? Great. Now that we have all of that information, try the three questions, A, B, and C. Okay? That's it. Now I have the answer for A, B on the screen there, so I'm not going to waste time with that particular one. B, C. Now I tried to trick you here. On the screen, we have CB, but them ask for BC. So BC is the opposite way. How much of you all got 10B? Positive 10B. That's a slight trick, right? But it's still a trick. Great. So the next one here is OB. What is OB, right? Draw the line connecting O to B. Now, there are two ways to walk from O to B, but you're starting at O because that's what the question said. Start at O. I think I proved it earlier on. It doesn't matter which route you take. You know, once you choose one of them. I'm just going to go the top route. O to A to B. So let's try that. Let's put on the plan for the examiner. O to A, and then A to B. O to A is with the arrow. You're not changing nothing there, minus 10B. And AB is with the arrow also. So it seems like there's no changes over here. All right. Add up all the A's and add up all the B's. 2A, well, he has no friends, so he's just 2A. And minus 10B minus B is minus 11B. How much of you all got that, right? And I should put my answer on the diagram. It could be useful later on. Great. So let's work out the last one, right? Let's work out C A. You're journeying from C and you're trying to reach A. Now there are two ways, obviously. You could go the top route, you could go the underneath route. I'm going to go the underneath route this time, but make sure I put on the plan for the examiner. You're going to go from C to O, and then from O to A. CO against the arrow. Make the signs the opposite here. Minus 2A plus B. And OA is with the arrow. So you don't change a thing. Okay? Add up all the A's, you'll get minus 2A. 1B minus 10B is minus 9B. Right? Let me know how that went, if you all got those answers.